announcements before we get started. So the chapter 1 of the Zeit book was due like today. If you haven't done it yet, you still have time. Get it into me by the end of the day. I am going to check that first thing tomorrow morning. Or if I'm feeling really adventurous, I might check it in the middle of the night tonight. I'll definitely check it Friday, right? But after midnight counts is Friday. So just be warned that it is, in fact, due today. Lab 2 is due on Tuesday. If we have some time today, we might have a little extra time today to go around and see if people need help with Lab 2. You do have to do a demo. So as a reminder,
Lab 1, right?
Or Lab 1, I'm sorry. Lab 1. Yes. Lab 1. Lab 1. The reason I said Lab 2 is because I'm in the process of getting Lab 2 ready to push out to you guys very soon. So there will be another homework assignment next week. That will probably be the last one that we can squeeze in before the exam, which is 2 weeks from today. So you'll have at least one more homework assignment before the exam. I do have a review session on the schedule for the exam as well. So I feel like there was something else I need to say. Oh yeah, for Lab 1, you do have to demo. You have to demo that thing, and you have to bring the demo form to the TAs when you demo. I've had multiple reports from my TAs that people don't bring the form with them when they try to do the demo. You have to bring that form with you. It's on the lab write-up. It's the very last page. Right? It's very last page. So bring all of your materials and that form with you to the demo. They're going to want to see your truth table and your schematic as well. You can show up your schematic on the computer, I guess, but they are going to want to see your truth table and the other pieces of that as well. So bring that to your demo. Any other questions about administrative stuff? Yes? Yes. Oh, thank you for reminding me. Homework 1 is so close to being graded, not quite done yet. That's going to be back on Tuesday. That's a promise. You're going to get that back on Tuesday. I will also post an answer key to that so that you can use it to help you study for the upcoming exam. Yes, that is coming back very soon. Thanks for asking. Any other questions that I can answer right now? The homework scores were very good, at least the ones that I've seen so far, once I've gotten back. So there shouldn't be any surprises there, I don't think. Was there anything else that I need to announce? I don't think that there was. So we only have a few more class sessions left before the exam. This stuff today is completely different than the stuff we've been working on up until this point, right? We're going to be doing a lot more coding in VHDL. Hopefully Lab 2 will have you writing some VHDL code, but today we're going to write some VHDL code as well. So this is the process of taking our designs, right, and prepping them for simulation. So before we write some code, let's just go over some of the basics, right? Who can tell me the difference between an entity and the components in VHDL? Somebody explain that to me? Nobody? Yeah.
Is it a component used in the test bench? Like was that an entity in the test bench?
Components are in fact used for a test bench. That's used in test benches. That's correct, but they don't have to be either. Yes. So you have seen components used there. They don't have to be used in a test bench. What does an entity contain? When I define an entity, what's in there? What does an entity have? Nobody? Yeah. Yeah, so what's in the declaration part of the entity? The inputs and outputs, right? If we think of it like a chip, right? Those would be pins, basically, going into and out of my circuit level components, right? So the second thing you said was architecture, right? I think that's kind of the second question. What's the difference between an entity and an architecture? So are they in fact the same thing? Does an entity contain an architecture? Kind of, right? What does the architecture represent in the entity? What does architecture represent in VHDL? So the entity is my inputs and outputs. Architecture then is what? Yeah. It's behavior. It's what I want this thing to do, right? here's a question that, here's a little curveball question, I guess. How many architectures can I have for a given entity? I don't know that you have seen this before, but anybody have any guesses? 2? Undefined? As many as you want. I can actually have lots and lots of architectures for a given entity. So maybe that'll help kind of drive that the point of an entity home. Right? An entity is, you can think of it as method specification, right? That if I'm talking about Java, for example, or C++, or your language of choice, if I'm defining a method or a function, that first line tells me what's going to come in and what's going out, right? I've got my input parameters, I got my return type. That's basically the entity, right? That's basically the entity. The architecture then kind of corresponds to the body of that method. What is this thing actually going to do, right? The big important difference here is that we're not talking about software. We're actually using code to represent hardware. So everything that I write in VHDL has to have a hardware analog component to it, right? It has to be able to be turned into a hardware circuit. Right? That's kind of the whole point of using VHDL. We're using it to model circuits. So what does that mean? An entity, right? I can define the behavior of a component in many different ways. There's often multiple ways that I can define the same sets of behaviors. So an entity is really just inputs and output specifications. The behaviors, then the architecture is the behaviors, and I can have many different ways of specifying that behavior. Think overloaded methods in a sense, right? Might be a good analogy to use there. So then back to the first one. We didn't quite finish that answer yet. Does that kind of help anybody form your answer to the first one? What's the difference between an entity and a component? Does that help at all? Maybe it would help if I pulled up an example, perhaps, in Xilinx. Let me see if I have an example I can pull up really quickly here. Because sometimes we see them in the same file. If you watched my videos, for example, you would have seen entities and components in the same file. So let me, where are my projects? Shifter, I think, is one. Oh yeah, this is actually the same one that I used in the video, as a matter of fact. So here's my entity definition up top, right? In this particular case, I only have one architecture, but hey, take a look. Here's my component, right? So what's the difference? Why do I have both in the same file? What am I doing here? I have the entity and the component right next to each other. What's the difference? They look very similar even, right? What's the difference? Well, think of it this way. An entity, I just said, is a definition of inputs and outputs. I can have many different behaviors, right? Many different architectures for a given entity. So, one such architecture uses this component as part of its behavior. Another such architecture might not use this component as part of its behavior. It might use a totally different component as part of its behavior, right? So a component is meant to be an actual implementation, right? An actual piece of the puzzle that I want to use to define the behavior of an entity. So an entity is like the definition. We can think of using components inside of behaviors as sort of the same thing as instantiating an object that I want to use, right? Creating a new object for me to play around with. Does that kind of make sense? And so then when I actually perform the instantiation, that occurs down here. Here is where I'm saying this is the component that I want to create, and then I have to map the inputs and outputs to this particular component. Okay? So here I'm telling it, I'm giving it the values that it needs to do its job. Does that kind of help clarify things a bit? Hopefully? I know it's a little confusing at first. It seems like you're duplicating a lot of stuff. And it can be hard to see why that's the case. But it is a necessary part of VHDL. Who's got questions? Do we have questions? Because I'm going to ask you to write some of this stuff here pretty soon. No? Okay. Let's move on then. Let's see what else we got. What's a process? So how does VHDL behave differently with or without a process? Where do I find processes in VHDL? Where do those show up? Yeah. Inside the architecture. Great. Perfect. So what's it for? What is the whole deal? How does a process behave differently than without a process? I can do both, right? I don't need a process. Sometimes I do, but for the stuff that we're doing so far, we don't need a process. How does it work? Yeah, go ahead.
The statements in the process execute when the process changes or one of them changes, then the process
Sure.
body can actually evaluate it.
Yeah, exactly. So a process, what is that called? Do you remember what that's called? You were saying, when the inputs change, right, it causes what are those inputs called? What's that called? Yeah. Sensitivity list, yes. So the process has a sensitivity list. Yeah, whenever anything in the sensitivity list changes, the process will execute again. Think about what that means. I'm using the process as part of my definition of behavior of a circuit, right? So whenever a value in a circuit changes, that causes kind of a ripple effect, right? That's going to change other values that proceed down the circuit. That's what the process is trying to represent here, right? So that explains, what a process is. The second question is still kind of open. This one's actually really tough. Does anybody have an idea of what the difference is between using a process and not using a process? I showed, in fact, on the video, I don't think I used any processes, but in the textbook they did use processes. Let me explain what the difference between using a process and not using a process is. If I have code that doesn't use a process, I know I have an example of that. That's not a good example. Let me open this up. Here's a good example, right? This is a behavior, right? An architecture. There's no process, right? It's just straight behavior defined as a series of statements. How are these statements being executed? What order do these statements run in? Yeah. All at the same time, right? All at the same time. Why? Why is that the case? It's really frustrating and kind of confusing to think about all of those executing at the same time. It's counterintuitive to everything you've learned about in programming in other languages, right? Why is that a necessary part of this? Yeah. Right. Hardware doesn't do one line at a time, right? If a value on a circuit changes, then all of the other things connected to that value change immediately, right? At the same time. We're simulating circuits here, so this stuff's all going to happen simultaneously. All going to happen at the same time. That's confusing. That's frustrating, right, for programmers to think about. We don't like that. Humans don't think that way. Humans think one step at a time. That's why we have processes. How does a process execute? A process executes one line at a time. A process starts at the top and works its way down towards the bottom. But wait a second. We're simulating circuits, right? So, that's not really an accurate representation of how a circuit behaves. Isn't that going to break things if we only execute one line at a time? Well, there's a trick that VHDL uses to kind of get around that problem. Where's the marker? If I have a process here with my sensitivity list, okay, and I start doing some assignment statements inside of here, I don't care what these actual assignments are. That's not important. Let's say I have another assignment to X down here, right? And then the process ends. So I just said that a process executes sequentially, and it does. But there's one very important feature of a process, which is that variable assignments are queued up, and they don't actually execute until the very end of the process. So any signal assignments that I have within a process all execute simultaneously at the very end of the process. So I can use a process to help me break things down sequentially, but this assignment to X here basically doesn't happen, right? This assignment to X is going to overwrite this one. This one will never actually happen. I might still want to do this. Maybe X is part of my definition here, right? So that value of x matters in a sense. What happens to z, but this value of x will never be seen in the circuit simulation at all, ever, 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 because this value overrides it and assignments take place at the very end. Does that make sense? That's how we can kind of cheat a little bit, have our sequential execution, but still be able to simulate a circuit faithfully. Right? It's a necessary compromise. Are there any questions? I see a couple confused faces. Any questions? Yes?
Also, in fact, what would be the current value for these assignments if
What would be the, I mean, so, maybe I want to do something with this value of x later on. This is a very simple example, right? But I could do something else with x in between. And because it's actually executing sequentially, that would have an effect on this current value of x, even though I never even see that value of x there. Right? So it can still have an effect to do multiple assignments like this. You just have to realize that the final value is going to be the last one. So if you want to know what the output of a process is, what the result of a process, there's no real output, right? The signals change. Any signal that gets touched in this process is going to change, right? That's the output, quote unquote. If you want to know what that's going to be, you start from the bottom and work your way up. Right? Kind of. Or start from the top and work your way down, and you'll eventually get it too. Any other questions? This will all make a lot more sense when you practice this and you write your first process and it fails miserably and you forget that assignments don't take place until the end of the process. And then myself or the TAs will remind you and you'll be like, oh, right. And then it will all make sense at that point. Right? Any questions before we move on to some more fun stuff? All right, let's try this out. Let's try and write some code. I think the remaining examples all involve code writing. Well, this is code interpreting, I suppose, and a little bit of code writing. So here's a very simple VHDL set of VHDL expressions, right? Your task is to draw the circuit that implements that's implemented by these set of VHDL expressions. So it's one single circuit. And then I have a couple of code writing exercises based on this circuit down below. Take a few minutes, talk to your neighbors. If you have your laptop, you could even fire up Xilinx and try to code it up in there, right? See if it works or not. That's what I'm going to do when we answer these in a few minutes. So. I gotta go to the bathroom. Yes.
You can do so you want to keep them separate. Like it's just here's all of the assembly code that you need to figure out what it does.
Something like this.
But it's
You put a slash and then the number.
yeah.
Then
Yeah, it absolutely is big. I want to accelerate because I was wondering if you could step into the GDB, the phase one, and you can step in there, which makes complete sense. Because we don't have the source code for one, we only have the binary. The binary for things like that. And so of course you can step in, so you can disassemble things from and then you figure out what phase one does based on the assembly. GDB program. And then disassemble phase one. And then figure out what phase one does. Figure out give phase one to diffuse the one. And phase one seems pretty because essentially I found a tells you the condition which these turns values are functions. Is that is she didn't even know how to do that. Maybe let's do that about for x86 yeah, I just searched on assembly GG x86 and it has 12 assembly functions. And it also seems like there's some assembly code in there that you can put in because there's like a rate of subtraction on any condition in there. And I think there's an estimate of that. Sure.
I mean, I can try to Yeah. No, don't be sorry. Don't be sorry. my circuit. So kind of a curveball, right? How do you deal with Z? I know Z has 2 bits. How do I represent that in the circuit? You can see what I did here. Z sub 0, Z sub 1. I can use that to represent each individual bit. Right? What's the AND for? Concatenation, right, which we're going to see a lot when we're dealing with vectors. Everything else, I think, should be fairly self-explanatory. These convert directly into logic gates. So inputs going into logic gates, outputs coming out. Right? We've got 4 inputs and technically 3 outputs since these are grouped together. If you want to represent these as a single group, you can do that as well. The way to do that is to put a slash across the line with the number of bits that it contains. We're going to start seeing this more and more as we start dealing with larger and larger vectors as we move throughout the class. And then you can just write this as terrible. As Z. Any questions about this process? Yes.
So for that notation, is there any implications to what condition is?
Yeah, that's the problematic piece with this. Typically, you don't see lines just joining up like this. Usually you see it as a result of an output from a pin or a component. That's much more common. So you can see it directly coming out here. But we couldn't do that in this case. We're not going to see this situation happen very often, if at all. I kind of prefer this notation actually in this scenario, because then I know exactly what's what. Right? Okay. Take a couple more minutes and see if you can do some of these coding exercises while I get stuff prepped up here. So if you have your computer and you have Xilinx installed on it, this problem was, that the entity problem was probably a piece of cake, although you probably haven't done it before, so it might have required a little bit of deduction on your part. When I create a new VHDL file in Xilinx, it pops up this window and it lets me specify what my inputs and outputs are. So you can see I just typed in the names that I wanted for all of my different ports, selected whether I wanted them to be inputs and outputs, and then for the vectors, for the ones that have multiple bits, those are buses, right, in our circuit. Then I have an additional choice. What's my most significant bit and what's my least significant bit? So think about it in terms of this is position 0 and this is position 1, right? So my I could have done it the other way, and I think it would have worked just fine in this particular example. In fact, I probably should do it that way since that's the way that we're used to thinking about it. The most significant bit with 1 and least significant bit with 0. But we haven't really talked about most significant, least significant in terms of what that implies. We're just saying the bigger numbers here are on the left, right? So the farther left I go, the more significant they are, the larger the values are. I can actually flip-flop that so that the most significant values are on the right-hand side, which is useful in some cases. We'll see some examples of that a bit later on. But for most things, we'll keep the most significant bit on the left. So that's what I'll go ahead and do here. The nice thing about Xilinx is you never have to really write an entity definition yourself. You can just have it generate it for you. So then if I scroll down here, here is my entity definition, right, for problem number 1. Now, this is nice and all, but you're not going to have Xilinx on the exam, so you still kind of need to know how to do this a little bit. Have a general idea of how this works and what these pieces mean, including these different data types, standard logic and standard logic vector. Those are the two big ones that we're going to need the most, right, over the course of the semester. And then I should ideally be able to copy paste this in and have it work. So, yeah. Oh, indent, please. Okay. Cool. Right. And so this entire file should take care of implementing this particular circuit. Should all take place. Notice I didn't include a process. That's perfectly okay. I don't need one. I think this is simple enough without a process. I don't need one. But you certainly could rewrite it with a process. In fact, I may ask you to do that in just a few minutes. How would this entity definition change if A through D were in a vector? What would that look like? What would need to change in this entity definition if A through D were all contained within a single bus? What do I need to do? Yeah. Mm-hmm. Yeah. So I could do it just like this. I'll call it ABCD, right? And then call it a standard logic vector. And then I also, when I create a vector, I have to include, right, how many bits I expect this vector to contain, which in this case I need 4, so I'll say 3 down to 0. Much like you declare the size of an array before you use it. Same kind of idea. How would that change this code down here? What would I need to do then? Like, we don't have to do the whole thing, but what would I do then to this part? A doesn't exist anymore, so what do I need to say instead? Yeah, depending on how you organize it, sure. You could organize it either way. You just need to be consistent, right? You need to be consistent. Yep. So I just need to swap those out for bits from the vector, which is very much like vector indexing. Vector indexing, right? Vector addressing that you learned in Java or other languages. Great. Any questions about this? Yes.
This is a really nitpicky question. In the book, it was behavior, and then here's from behavior. Are they the same thing?
This is a name, so I can call this whatever I want.
It's just a name.
All right. Great question. Any other questions? Questions I can answer? Okay. Let's try some more practice problems then. There you go. We saw this one last time. We saw this last time. So you can try to write the entity if you want. I really only care a whole lot about the architecture, but do them both, I guess. We'll have to do them both eventually. So take a few minutes, talk to your neighbors, see if you can figure this one out. Oh yeah, we did simplify it, didn't we?
Yeah, we do have
What's the simplified one look like? I forget.
B naught C or AB.
Oh, it's so simple. I mean, yeah, whichever. It's good practice either way. Whichever. I'm gonna do this one, so you can do whichever one you want. So actually, I switched your process.
Alrighty.
So here's my entity definition for this circuit, right? Some of you noted that we did simplify this circuit quite significantly last time, which makes this a lot less code to have to write. But let's say I didn't know that, and I wanted to actually implement the circuit that was on this slide here. How many lines would I need to do this? How many lines did it take you guys? In theory, you just need one. Should you do it that way?
Yes.
No, you should not. No, you should not. What's a technique that we could use to make life a little easier for us?
You can.
Go ahead. You can do each gate individually, right? But where am I going to stick the output of each gate? How am I going to do that? Yeah.
What you can do is we have a sum of products from last time, and you can just like put one thing into X and then do X is equal to X is current or the next thing.
Okay, I kind of see what you're saying. So we just continuously reset the value of X?
Yeah, and or with its current value.
Right. So, okay. I think that may work, but I think it would require an additional very important code construct to happen. Does anybody understand what I'm getting at here? Like, can I just start doing that now? What's the problem with this? Right, if I start saying A and B here, and then on the next line I say X is equal to something else, X or C. I don't think this is actually right. What's the problem with this? Yeah. These are all trying to run simultaneously, so it's not going to like that. But you were exactly right. If it's taken into a process, that might actually work. Yes. Processes run all the variables once at the very end of the process. Stuff that's not inside of a process is going to run simultaneously, just all at once. So every single line, even though it looks like there's an order to them, there's no order. You can jumble these lines in any order you want, and they would still give you the same outcome. So when I try to assign the same variable twice, that becomes problematic. Yes?
Did a process in lines with all the other lines still execute simultaneously?
If you had a process in between lines? Oh, you mean I have some stuff in a process, some stuff out of a process? Yeah. The stuff that's outside of the process will run simultaneously. The stuff that's inside of a process will behave like the process normally does. And then that process then has to actually execute before the other lines do, because it will then be part of that simultaneous execution of those other lines. Does that make sense? I have to run through the process and get the results of those signals so that I can set those simultaneously with the other signals. Right? Okay. Back to the task at hand. So if we use a process, this method works very well. If we don't use a process, this method I think is a bit problematic. What if I really, really, really don't want to use a process? What could I use to help me out so I don't have to write this all in one line? Yeah?
You could go like x1 equals a and b, and then x2 equals x and c.
Sure. And what's x1 and x2? What are those? How do I make those? What do I do? I'm sorry? Oh, like a bus. I see what you're saying. So I could turn x into a bus. That's not an accurate representation of my circuit, though, to make x a bus. So my output then would become multiple bits, but my output really is only one bit, right? I thought you were actually alluding to something else. That would work. It would just give me extra baggage that I don't necessarily want. There's another technique that I talked about in the videos that would help us here. Yeah. You can use signals, right? So in my architecture, I can say stuff like signal x1. I'm probably doing this syntax wrong, actually. No, this is right. Standard logic. And now I have what is essentially a variable, right, that I can set. Okay. But again, remember that these variables are also going to be set. All this stuff is going to be executing simultaneously, right? So if I have any of these intermediate values, what's going to happen? Well, it's like I'm linking them up. It's like I'm drawing traces onto a circuit board and hooking all those things up. Right? So that would help you piece it together one piece at a time. Does that make sense? It's a great way of breaking things down into chunks. Even if you have processes, it could be useful to inject some signals in there to help you break things down a little bit. Right? Okay, let's try another one. All right, we haven't actually, well, I did talk about conditionals in the video. If you watched the video, right? We saw some stuff like this in the video, in the VHDL in the video. I'm saying that this can actually be rewritten without these, right? Without these when statements. So take a few minutes and see if you can reason through what that looks like. What do these look like without the when statements? Notice there's no process here either, right? Process free. Yeah.
What's the convention in VHDL for like when you have A ampersand D? Does A go into 1 or does A go into 0? Given that. Okay, and since you put Y as 1 to 0,
1 down to 0.
1 down to 0, A would go to 1. D. Thank you.
But we need to,
Yeah, we need expression. B and C.
Who thinks they have it? Who thinks they got it? Anybody? Anybody think they got this? Nobody thinks they got this? All right, take a few more minutes then. Who can give me some help? How would I start figuring this out? What would you do? Yeah.
Well, for X, you can draw a truth table that just has A, B, and C in it, and that tells you the X truth table.
Yep. Yeah.
B doesn't actually matter because you only get A or B if A is M.
You only get to A or D if A is 1.
Not necessarily. If A is 1 and B is 0, then you get not C.
Right. Well, I think he's saying that because I rule out A as 0 here, I know that if I execute this line, A is going to be 1 no matter what. So true. Right? That's what he's saying. So you can make a little simplification. Your first part, though, is what intrigued me the most, which is create a truth table. That's what I would do. I would create a truth table for this whole shebang. Actually, I know we've got 4 inputs. That's 16 possible combinations. I know that seems kind of like a lot. So if you don't want to do every single possible one, what you can try to do is look for the true combinations, right? Look for the ones that are going to make things work for you. Right? So I know that A equals 0, B, and C, right, is a possible combination for X. So 0, A, B, C, 1, 1. Right? A is false, B and C are true. Right? That will lead to X being true. If B or C are false, then X will be 0 in that particular case. D, in this particular case, doesn't matter. So if we want to incorporate D, that actually gives us 2 conditions, right? These both are represented by that particular expression, since D isn't included. these are two terms for x. Right? The next line here, when a is greater than b, that can only happen when a is 1 and b is 0, correct? So when a is 1 and b is 0, that's another 4 possible combinations if I'm looking at all 4 inputs. Or if you use the simplification that was provided, we can ignore this 4th input, and that does simplify things quite a bit. But we also want, well, I guess, yeah, we want c to be low here, so that's actually only 2. Right? Yeah. So far we're up to 4 combinations for x. Right? And then finally, the last combination is a or b, which would be 0, 1, which we already have, right? We actually already have 2 of those combinations. Well, just 1 of those combinations. We just need the remaining 3, I guess. This one we already have, so I don't need it again. We need 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. So then you should be able to create minterms out of these, right? Create minterms out of these guys. Construct an equation for x, and then turn that into your expression. You could run some simplifications on this before you do that too, right? You don't need to specify the entire minterm. That would be a long statement. And then for y, it's a little bit trickier, but it's basically the same process, right? For y, I just have 2 bits. So how do I solve that problem? Using this mechanism? I mean, I can treat each bit independently, right? If I want to, I can just split them up and create a truth table for each one. So do y0 and y1 separately from one another, and write expressions for those as well. Okay. Does that make sense? So I've already made this point several times. Everything that you have in VHDL is eventually going to turn into a component on a circuit, right? You look at this conditional and you're like, what the heck kind of component does that turn into? Well, we just kind of proved that that can be broken down into logic gates. We proved that these conditional statements can be broken down into logic gates that we know. In fact, next week, we'll see another way to represent these conditional statements in our circuits. It's a little bit easier for us to manipulate. But for the time being, we can rest safe assured that those can be represented by logic gates if necessary. Everything in VHDL can boil down. Well, that's kind of a lie, but almost everything in VHDL can be turned into a component in a circuit, which is an important property of the language. Any questions? Any questions about that process? Comments? I think I have one more problem. We still have 15 minutes, right? This is kind of like your lab, almost. So you're given this truth table with four inputs, 4 outputs, right? Take the remaining 15 minutes and see, or, it might be better actually, as I kind of promised towards the beginning, if you spent the last 15 minutes working on your lab. That might be a good idea too. If you want me to do a demo, I'm happy to do that if you have the demo form with you. If not, you can run it and print it out and bring it back real quick. I'd be happy to knock that out for you. Elliot will be around too. If you have questions on this problem, we'll be around as well. Treat this is like office hours. Why? I do.
I have a question just without lesson. On that, so how do you set that? But I have a mouse and a button. But I try and run it
Urban second floor. Urban second floor is like 50 all the years.
I have
no, you can't. The ones in that. I'm looking in there. It's much easier for me to
After hours this morning, all of that was being talked.
Otherwise, you guys can't do it. That's probably how you want to do it.
that's what I'm also looking at how to do that would be the best way.
projects. Down at the very bottom, some projects. Okay. And then where it says model students, scroll down. Just switch it to say IC instead. There's a model. Switch that to say IC and then try to run your simulation again. And I guess what is probably for you. So I can go just a question of the language itself.
Okay.
Because you see, I have not managed to download it yet.
That's fine.
So how sensitive and spacing sensitive is
I don't think it's very space sensitive at all.
I think I'm going to do that. Use lowercase 4 on one of these later slides.
I don't think it cares, honestly. I think VHDL is pretty reasonable when it comes to case sensitivity, but let me just Google it real quick so that I don't case sensitive, yeah, it doesn't care.
Okay, and this, how much is the spacing like? Obviously, there's some sort of active up there. There was, for example, in curve that you get rid of the
I think so. Well, I don't know if you can make it all one word like that. You have to have a space between the B and the colon. I think it's colon and operator.
Okay,
I have to try. I mean, even if you could get away with it, you want to write it. You want to write good code, especially. I'm not going to be grading on style like they do in 131 necessarily, but maybe some hideous code and just fix it.
yeah. Also, one more thing.
Sure.
Are there any earlier you mentioned that you could set your own water?
Yeah, it should already be installed and ready to go on the board. I've heard other people have installed it. Hour labs will work, and then the Brian 316 labs where the TA office hours are, which work. So just the whole tile labs are on the board.
And you did have other
If you can use it for computer science classes,
this is the fun part where I think I've written off the year. Yeah.
yeah. The code for this lab is super easy. Schematics more. Oh, yeah. Hold that. Just be so much for it. That's fine. I think I'll figure it out. I don't think we can do that one. Yeah. Yeah. All the other. Exactly. I guess that's schematic? Yes. Looks very beautiful. Let me grab a camera. Pencils. Not that first time. No, it looks great.
So even that kind of nice way where it's less slash prime, so that it's zero shot.
Yeah, I didn't. Oh, it's good. Test bench is next up on the list. So a lot of this stuff is created for you, right?
Yeah, auto-generated.
There's your stuff.
Giving every combination of any inputs.
You even did it in a logical order.
I basically just
Good.
Yeah.
Good. That's good. And then simulated forming.
I ended up using Python.
That's fine. That's not a problem. Expand it out. And simulate.
Yeah, I could not get mouse here.
Yeah, I have that same problem. Zoom out. If you hit the one with the X on it, it shows you all of it. Yeah, it should just look like you're coding, right? So LR is low and then it goes high, so you should see your.
These aren't in order.
When you print this out, did you put those in order for me?
I did.
Oh, you have to print out. Fantastic. Yeah, that will be much easier for us to create. Okay. Absolutely. I like seeing it. It's good. It looks great, man.
Okay. So then I guess
Actually, could I have the pen?
Do you want them? Does it make all
Is it
of
fancy? That's good. That's good to know. Is that I've had lots of people struggle with normal sin, and I don't know. Okay, so I need to go punch this in online so I have a hard copy, and then